In this video, we're going to look at topic 76, example 3, applying a linear quadratic system. Andrew throws a ball up a hill for his dog, Laika, to chase. Laika, I'm not sure how to say that, I should have changed it. The hill is modeled by a line y equals 0.5x, so that's going to be the blue line. And the path of the ball is modeled by the quadratic function y equals negative 0.5x squared plus 6x. That'll be this red one here. How far does the ball travel horizontally? So that's question 1. And how far must Laika run up the hill to catch it? Really have no idea how to say that. I should have figured that out. So what we're looking for is the intersection points of our quadratic and linear functions, functions. We know the first one is going to be 0, 0, right? That's the bottom of the hill, and that's before Andrew's thrown the ball. And then the second one, we're looking for this x value. All right, whatever this happens to be, that's going to be our answer to question 1, how far does the ball travel horizontally? We're looking for that value there. So I'm going to write out our system. We have y equals 0.5x and y equals negative 0.5x squared plus 6x. And since they're both equal to y, I can use substitution and I can set them equal to one another. Right, so they're both equal to y, then they have to be equal to one another. I now have an equation that only has x, so I can work on solving this. Let's get our like terms together. So we'd have 0 equals negative 0.5x squared plus 5.5x. I know that we're going to have to factor this just by looking at it. Maybe you realize that right away, maybe you don't. But as you get better at these, or not so much better, as you do them more often, you start to kind of see patterns and start to see what you'll look at. But what I do not really want to deal with is these decimals. So I'm actually going to multiply this entire equation by 10. That way my decimals go away. All right, and remember, you're allowed to do that as long as everything is multiplied by the same number. Okay, you didn't have to do that, but I feel like it makes the problem easier to work with. So I'm now going to factor. It's more obvious that these have a 5 in common, or let's say a negative 5x in common. I'm going to take out that whole thing. So we're left with x minus 11. All right, you could have done that and kind of gotten the same thing if you did that at this step up here, but for my purposes, or as I'm solving this, I like to deal with it without decimals if I can. Now, I can use the zero product property and set each of these pieces equal to 0. So this one is obvious, but we'll write it anyway. X is equal to 0. That's where we talked about that first point. So this x equals 0. That's this point here at 0, 0. The second one would be, we would add 11. And at that point, this x equals 11. That's our second one. It's our second point. And that's the horizontal number, the x value that we were looking for. So we figured it was probably going to be around 11. We didn't know that exactly, but now we do. So our first question is answered, right? How far does the ball travel horizontally? Well, we know that this coordinate point has an x value of 11. We don't know the y value yet, but we will figure that out. So how far does the ball travel horizontally? We could say the ball travels 11 feet horizontally, or horizontally 11 feet, however you want to phrase it. So that's the answer to question 1. The ball travels 11 feet horizontally. Next question, how far must Laika run up the hill to catch the ball? Now, this one's a little bit more of interpreting the graph. Without looking at the graph, we might not know this right away. But what we do need to figure out is we need to figure out what this y value is here. All right, and to do that, what I could do is I could take my y equals 0.5x, and I can plug in my value of 11, and that tells me that y is equal to 5.5. So that 5.5 I'm going to plug in there. and then we already have the x is 11. Okay. So does that tell me the answer? No, that doesn't tell me how far that the dog needs to run up the hill. What it does tell me, though, is that if I look at this, I don't want to show this. Let's shade this. Right here, I have a right triangle. Right? And if I take that right triangle and draw a little sketch of it, I know that this bottom piece is 11. Right, the length, that's 11. The height we now know is 5.5. And this is my unknown value. Let's call this c because we're going to use Pythagoras Theorem. So using Pythagoras Theorem, c squared equals a squared plus b squared, I can then figure out what the c value is. Okay, so we're going to plug our numbers in. C squared would equal 11 squared plus 5.5 squared. I'm not going to show all the steps. I have the answer written out, so I'm just going to take that answer. But what's going to happen is that C is going to be equal to 12.3, or approximately 12.3. So the question, how far must Leica run up the hill to catch it? So Leica has to run 12.3. Did they tell us whether it's meters? They don't really tell us. We never find out what this is, do we? All right, we're just going to say feet. So Leica has to run 12.3 feet. And that would be the solution to question number 2. You really should be more concerned with question number 1. You'll have to do that a little bit more frequently, really solving for x using substitution in a linear quadratic system. I know it's got a little messy and a little cramped up, but to find that value, and you might not even seen that, maybe on your own, you're not going to realize that, hey, this is a right triangle. I can use, Pythagoras Theorem to get that. If you realize that, great. If you didn't, don't worry about it. It's not the end of the world. Just kind of your goal should be to understand what's going on in this situation, right? Not every situation will be the same. So just realize that there's going to be times where you're going to have to try to figure things out, and it won't always be the easiest, and it won't always be obvious to you right away. But if you apply the things that you know, eventually you will find that right answer.